So welcome to Computer Science 2. I'm Dr. Chris Burke. About 40 people have joined us online for the live stream, and we've got seven folks here. Great. And unfortunately, we missed our first class on Tuesday. That's all right. We're going to make up for it today. I'm still going to give you an introduction to the course, of course. And Then we'll, as soon as possible, we'll get right into our first topic, which is going to be Java for this section. First of all, making sure that everything is working online. Good. If you are online, or if you're in here and want to join us online, there is a live Q&A session that has been started on Piazza. You can go to that and just make a follow-up question if you don't want to raise your hand or whatever. Feel free to raise your hand, though, if you are attending in person, because I've got open backs. I can hear you just fine. Okay? So, as I said, my name is Dr. Chris Burke. You can just call me Burke or Chris, whatever you want. And this is CSCE 156. This is the main section. And it's basically computer science 2. I've been doing this course now for about 10 years or so. Each time we do something a little bit different. And so I'll show you what we're going to do different this time. In fact, there are several things that we're going to do different today because of COVID, or in this semester, at least. All right? But what I want to do is I want to start out by giving you a course overview. That is the theme of this course. What is the purpose of this course? Then we'll get into the nitty-gritty details of the actual schedule, your assessment, which is based entirely on labs and assignments. And those assignments are actually, after assignment 1, those assignments are a series of phases in an overall semester-long project, okay? So when I say project, I mean assignments. They're synonymous in this case. I think it's 6 different phases. Along with that, you'll be maintaining what's called a design document, an IEEE formal design document on documenting how you design this system, okay? And this semester, the theme of this system is you are building an inventory and sales system for a regional used game store, right? This was made way before the current GME debacle, so it has nothing to do with the current events if you're familiar with those. We'll talk about how to collaborate with your fellow students and the rules that go with those collaborations and the resources that we're going to provide to get this project done. And then we'll go over generally the course resources, including the syllabus. Again, I'm monitoring on Piazza here. If you are on YouTube, of course, the chat is open, but I'm going to mostly focus on the Piazza Q&A. Last semester, people did, or at least one person established an overall Discord for everybody. If they want to continue that, that's fine. That Discord hasn't been posted to since the end of the semester, but if you want to revive it, go ahead, okay? So the theme of the course is, of course, this is Computer Science 2, so we've assumed that you've taken Computer Science 1 or the equivalent at some other institution, which basically means that you have working knowledge of at least one high-level programming language. Does not necessarily have to be Java. That's going to be our first topic for this course, is we're going to cover the basics of Java. But at the end of a typical Computer Science 1 course, which is all about problem solving with computers, you should be able to approach a reasonably complex problem, design a top-down solution, and code a program in a high-level programming language to automate those solutions. What do we mean by top-down? Means that you can take a problem and break it down into smaller and smaller pieces until those pieces are so small that even a dumb computer can do it, right? Meaning that you can translate that to an actual program for the last part of that, right? The key realizations that you should come out of a Computer Science 1 course are that computers and programs are not problem solvers. There's still a human element there. Humans are problem solvers. You solve those problems. Computers are dumb. They do exactly what you tell them to do. If you tell them to delete the entire hard drive, they will delete the entire hard drive, right? Programs only automate solutions. Only after you've solved the problem by breaking it down into those small little pieces that even a dumb computer can understand, then can a computer take over and automate those solutions. And that's exemplified by this Douglas Adams quote. This is a truncated quote that I use in Computer Science 1 for its theme. By the time that you've sorted out a complicated idea into little steps that even a stupid machine can deal with, you've certainly learned something about it yourself. You've solved the problem as the human, all right? So how do you contrast that with Computer Science 2? Just making sure that everything is fine online. All right. By the end of Computer Science 2, you should be able to approach a reasonably complex problem, so same premise, and ask design questions first, right? Instead of immediately breaking that problem down into small parts and, oh, I need a for loop for this, I need a variable for this, you should ask yourself what entities or objects are going to be necessary to model this problem, right? What classes should I create to represent this used video game store or a game itself, right? How would these objects interact with each other to solve this problem, right? And what data structures and algorithms can you bring to bear these off-the-shelf solutions that already exist? What can you take off the shelf to solve these problems and basically make the problem solving just one or two lines, right? It's a fundamentally different approach to problem solving because it's kind of a bottom-up kind of approach. Where you start at the bottom and say, I need this entity, and I can take that algorithm over there and that data structure over there, and I can mix them all together, and I've solved the problem, right? And it's exemplified by this quote from Eric S. Raymond, who I think it was in the Cathedral and the Bazaar. It's a book, a treatise on open source software. Smart data structures and dumb code work a lot better than the other way around, right? Okay. Maybe I should shut up. All right. We're getting some spam on the, but not on the YouTube, but we're not getting spam on live Q&A, which is what I'm actually paying attention to here. Okay. So here's our schedule, right? And it is a little bit truncated because of the 14 weeks, and of course we lost Monday. But it's okay, we can still pretty much keep this schedule because I've already designed it with some slack time in there. In the first few weeks, we're going to give you an introduction to Java. Now, already having a fundamental foundation in at least one high-level programming language, great, you're good to go. Once you learn one programming language, you just have to learn the syntax and nuances of another programming language. A for loop is basically the same in most programming languages. Even a programming language that tries to discourage the use of for loops, say like Python, you can still use for loops basically in Python. The concepts are the same. The syntax and the approach and the paradigms are just slightly different among all programming languages. Then we'll go ahead and pivot to object-oriented programming in the context of Java. We'll talk about database design and SQL, so we'll learn another programming language. SQL, structured query language, is a programming language. It's how you access a database. Then you'll bring those two things together and programmatically access your database through Java. Your Java program will connect to the database server and pull down data, persist data, save data to what basically talk to the server. Then we'll get into data structure. The second half of the course is all about data structures and algorithms. We'll start out with lists and list-based data structures. That includes stacks and queues, so that might be switched there. Algorithms, algorithm analysis, which you have some exposure to maybe from Computer Science 1. And of course, you'll get a reiteration of that in discrete structures. That's 235 at this university. That's discrete mathematics, basically. We'll talk about searching and sorting in the context of algorithms and algorithm analysis, stacks and queues, and then we'll get into more advanced data structures, binary search trees, tree-based data structures like binary search trees, heaps, and so forth. Okay? That's the approximate schedule there. Of course, you can go to Canvas to see the more detailed, and of course, that'll be updated as we go along as well. The two assessments that you have in this course are labs, which you've already experienced yesterday, and assignments. Just to reiterate about labs, they're weekly, so there are 14 labs. You're only graded out of 13, so we will drop your lowest lab grade. Right? That is not, you should not take that as carte blanche that, oh, I can skip this week's lab, I don't care. Right? Each lab is essential to getting you exposure and hands-on knowledge, hands-on working knowledge with the concepts for that week. Right? So don't rely on that token that you're going to have the lowest lab grade dropped. You can do it for those of you in an in-person section. You can go ahead and attend in person. That's going to be in the labs downstairs during your registered session. If you otherwise, regardless if you're on the online section or the in-person sections, You can always attend online if you want. Or otherwise, attendance is not mandatory, I should say, at least this semester. Attendance is only necessary if you want to work with a partner, or you have a question that needs to be answered by an LA, or if you just want a more structured environment for you doing your work, right? If you need to get away from your dorm room, or you need to get away from your apartment, or wherever you are, just so that you can work because there are too many distractions, then those labs are available for you, right? Otherwise, completion can be done asynchronously. We saw that more than 20% had completed the lab before Wednesday for the first lab anyway. All right? So each one has starter code that's available on GitHub. Each one has JUnit tests that have to pass. You do the code. You complete the tasks that are outlined in the lab. You pass all your tests locally by running those JUnit tests. You submit it to the web hand-in, the web grader, and we see all those tests, and I've already started putting in grades for lab 1. Looks like everybody's getting it. You get your 20 points, right? That's all that it's based on. It's based on completion, basically. You can work with anybody that you want. If you want to get into a group of 3, that's perfectly fine too. If you want to work alone, that's fine. But we highly encourage you to collaborate and work with somebody else just to stay on task. All right? That's labs. Now, assignments are the bulk of your grade. I think the labs are about 25% of your grade, but the assignments and the project, that's 75% of your grade. There are no exams, there are no quizzes. It's all based on this more formative assessment where you have basically 2 weeks for each phase of these assignments. And you can submit, you can resubmit, you can go back and change your design as much as you want up until the due dates. The first assignment is a little bit different from the other assignments in that it is a one-off. Because we're starting this course by introducing you to Java, basically we give you 3 programs that many of you probably have seen before. In fact, I took 2 of them from last semester's Computer Science 1 course. So if you took my CS1 course last semester, you've already done these in C. Now you'll do them in Java. But it's 3 basic programs, individual, no partners on those, right? You have to prove to yourself, basically, that you're prepared for this course by meeting the prerequisites of having taken a CS1 course or being familiar with at least one high-level programming language. If you can do that first assignment in the language that you're already familiar with, you should be good to go. If you can't because you don't have, or your coding skills, maybe you didn't pick up enough, or you relied on partners too much last semester, or it's been 3 years since you've coded a Hello World program, maybe you want to go back and start with Computer Science 1 instead, okay? But it's individuals, no partners. Otherwise, after that, the remaining assignments, all of them, are partner-based. Now, partners as in pairs, only 2 people into a group. No 3 pairs, no 4 pairs, right? That diminishes the responsibility, that diffuses the responsibility way too much. 2 is the perfect number for these kind of projects. And of course, there are 6 phases there, right? Yeah. Where the first phase, you do your basic class design along with EDI, which is electronic data interchange. You design your application in the second phase and produce a series of reports, sales reports. Then you go back and you design a database to support this business model. And then you load, instead of loading from a bunch of flat files like you do in phase 1, you load from the actual database that you just designed. And then you persist to the database, meaning that you save to the database. And then you design and integrate a sorted list ADT. We'll talk about that later, though. There is traditionally an assignment 8. Okay, it is required but not graded. That is one of the other accommodations that we've made for this course. It's written, it's theory, it's algorithms, algorithm analysis, basically all the stuff at the end, and usually it's graded. But one of the curricular adjustments that we made in response to the Faculty Senate resolution because of COVID is that we are not going to grade that towards your final grade. All right. A little bit more about the, can you change the name of the stream on the YouTube? No, I cannot. That is a bug that was introduced I think early last semester actually, in fact, if you go to that live URL, it no longer really works. It only resolves back to your channel. I don't know why they got rid of it. First of all, it was an undocumented feature, and then now they've taken that feature away. So unfortunately, I cannot. Sorry. Will you open up in-person classes to everyone if people don't show up for class? 1, 2, 3, 4, 5, 6, 7, 8. Yep, it's open. As long as, I mean, we've got, as long as there are seats, yes. And it looks like there are, I don't know, roughly double, triple that number. So yes, we will probably, starting next week, adjust it so that based on NUID you can come. But of course, with lab sections, if you can always attend in person if you're in section 150 or 160. Are there computers for us to use in in-person labs, or do we need to bring our own? There are computers down there. Of course, you're taking the risk that the keyboards are not clean necessarily after the last user is there. So I would still suggest bringing your own device, BYOD. Right? Good questions online. Right? I'll go ahead and resolve those. And if there are any more, again, please use the Piazza for any questions. Even if you're in here and you don't want to feel like you want to call yourself out by raising your hand. But if you do want to raise your hand, please let me know. All right, so a little bit more about the project phases. Again, it's a multi-phase theme project. This semester, it's Modern Geek Gaming. It's a used game store and inventory sales system. Basically, they have several different products like used video games, new video games, subscription services for online, Xbox Live or whatever. And they've got a bunch. It's all just fake data anyway. But you have to build this system to support this the chain of stores model of selling things. Right. Each phase is graded based on correctness and design. So make sure that you're taking a look at those rubrics to understand what we're looking for. Just because it runs and it outputs the same thing, that's really only about 40% of your grade, right? It's also got to have good style, good documentation, and good design, right? And each one of those elements, what we're looking for is enumerated in those rubrics. So keep that in mind. Not only that, but each phase, you have a design document draft, right? Now, this first one is due in, well, I guess 3 weeks now, but 1 week prior to each phase, you have to put together this design document, a new draft each time. So you're updating this draft. It's a living document. Basically, you're documenting what you're going to do, how you designed this phase or this part of the project. And you'll turn that in 1 week prior to the assignment. That's to get you to force you to get you to think about the design before you even start. Right? That's the idea there. And each draft is graded based on completion. I think it's only about 5% of the points for the design document. So you turn in a draft. We will assess it and give you a grade estimate that if this is what you turned in at the end of the semester, this is the grade that you're probably going to get, right? That's not the grade that you're going to get, though. You get 5 points for just turning in that draft. Only the last one counts towards your final grade. So you have 6, 7 different opportunities here to improve that design document, update it, and make it perfect, all right? And we've got several IEEE templates. If you want to use Word, that's fine. If you want to pick up LaTeX skills, that's fine too, right? We've got two versions for you to use there, right? Collaboration on projects is highly encouraged, but again, pairs, right? Do be careful though, right? Just because you have 2 people doesn't mean that you have half as much work. In fact, you might have more work because not only do you have to do the work, but you also have to collaborate. You have to speak to each other. You have to communicate. You have to resolve differences. If you make a design this way and your partner says, oh, I don't like that design, you have to go back and forth on that and discuss it. Which one is the better one, right? And maybe those arguments will win out. It must be an equal share of the work. You can't just partner up and say, okay, you do phase 1 and I'll do phase 2. And you do phase 3 and I'll do phase 4, right? Don't do that, right? That's not collaboration. That's not proper collaboration. But it is easy to bounce ideas off of each other. It's much easier to do rubber duck debugging if you're not looking at a rubber duck. Instead, you're talking to an actual physical human being there. It also gives you an opportunity to develop those soft skills that are always highly regarded and highly sought after. But the priority for teaching those is rather low because it is actually really difficult to teach them. Instead, soft skills are best learned by experience, right? Dealing with difficult people. If you partner up with somebody and they end up, one of the risks is that they can mooch, they can flake out, they can disappear, they could drop the course, leaving you to hold the bag, right? How do you deal with those things? That's the development of those soft skills. How do you communicate? You're not really pulling your weight here. I need you to, you haven't shown up to the last 3 meetings that we scheduled together. I'm really going to have to think about ending this partnership unless you start pulling your own weight. That kind of communication, that kind of developing that kind of assertiveness so that you could do something like that is an absolutely essential soft skill, right? Conflict resolution. Also, at the same time, don't be on the other end of that. Again, 2 people can partner up and then one person does all the work just because they're really highly confident and they want to micromanage everything and they've got to have their signature on everything. Maybe you want to work alone then, at least for this course. You're still going to have to learn how to deal with other people eventually in real life. So I would still suggest that you work on that if you're that kind of person. But that is another risk. Right? Don't undermine the learning experience of your partner by doing everything. Use Git if you're going to do this. Right? I put out a video, 0.2, on an introduction on how to use Git along with Eclipse. Use it and make sure that all of your code is in a private repository. To pair up, you actually go to Canvas, and in Canvas, let me pull up Canvas over here just to show you what I'm talking about. Here's Canvas. To pair up with somebody, you need to go to People. It's not going to look like this for you, but you need to go to Project Pairs, and then you and your partner need to join one of these groups. It doesn't look like anybody's joined yet, but of course you're not going to join into a partnership until after assignment 1 anyway. But you've got 50 or 60 project pairs here that you can join. You just need to collaborate and you say, all right, you join group number 42 and I'll join group number 42, right? That's, you need to do that for if you're going to partner up with somebody. Okay? Questions so far? No? Let's see. Assignments are due every Friday, 1 second before midnight. Right? A good question online. How do we get our labs checked off by an LA or a grade so that we can use the web grade, or you just use the web grader, right? There's because of the online nature of this course, I've changed everything so that it all has JUnit tests. You pass those JUnit tests. Unfortunately, it's just me grading those now, so I've gotten through about maybe 20% of them from yesterday. I hope to have them done by the end of every Thursday, and then I'll put out release the grades on Canvas along with a retrospective. Okay. Is it possible to work solo? Absolutely. If you especially if you're online or in a completely different time zone and you want to work alone, that's perfectly fine too. Who you partner up with, that's your business. We will facilitate that over on Piazza. If you take a look, there is a thread that's pinned at the top looking for teams or looking for partners. You can use that. You can use the Discord if somebody reestablishes it to look for a partner. However, if you want to break up with a partner and you're not fully comfortable doing so, or you want to know how should we go about doing this, because we worked on the code together, we realized we're not compatible. Is it okay we still both use the code that we worked together on? Yes, just talk to me and I can facilitate that. Okay. Good questions. So yes, it is possible to work solo. Right. But even solo had Chewy, so. All right. All right, so take the long view with this course. Make sure that you understand where we are going. Read all of the assignments now so that you know what the scope of the course is. Don't get started on phase 3 of the project already, because we haven't covered that stuff yet. Although I have seen people like asking questions about Lab 5. So some people are working ahead just because they're really gung-ho or whatever. And perfectly fine to do that if you want. Have a good, well thought out design on paper before you even open up Eclipse. And I'm going to give you a tool to do to help you better with that this semester in a second here. Design your own test cases before coding. That's actually required. And do it correctly. Do it by hand. Do it by some means other than your program. Right? Attend office hours, or I should say not office hours. We're calling them help hours. For anybody who doesn't know, office hours for the LAs and myself online on Zoom, that's where you can get help. Right? It's not just I have an administrative question that I need answered or something like that. We're there to help you, right? To resolve any problems that you might have with, say even if it's just an Eclipse setup problem, right? Stop by and ask us questions. Virtually, that is. More or less covered a lot of this, except for, again, one of the other themes of this course is smart data structures and dumb code are a lot better than the other way around. That's kind of the flip side of CS1 versus CS2. Way more emphasis on design in this course than simply correctness, say, like I would typically do in a computer science 1 course. And beware of technical debt, right? If you don't have time to do it right, or if you don't put in the time to do it right the first time, then you'll have to find time to do it over a second time, right? All right, let's see. So two new resources that I'm going to share with you to help you facilitate your project this semester. First of all, on collaboration, if you are going to collaborate with somebody, use Git, right? That's a given. It's an absolutely essential fundamental tool in computer science and coding, and if you're still not comfortable using it, you need to get comfortable using it. The second one that I want to bring to your attention is Saros, which I believe that's how it's pronounced. But since we're encouraging you to use Eclipse, you don't have to use Eclipse if you don't want to. If you hate Eclipse, fine. Go off and use IntelliJ, right? I don't have the $500 a year that it would cost me to use it. As students, it's free for you until you're no longer students. So keep that in mind. That if you spend the next 4 years getting used to IntelliJ and you fall in love with it, you've got a bill coming due when you're no longer a student if you want to continue using it. But Eclipse is completely 100% free. There's a nice little plugin that allows you to work with your partner virtually by sharing. It's not just a screen share. Both of you can manipulate the mouse. Both of you can type on the same, basically there's a server and a host, or a server and a client. Whoever is the host, that's the one that you're working on. But you can have, I think, multiple people actually connect, but of course you're only gonna have 2 because of partnerships, pairs. But both of you can type in the same window, basically, right? And I think that it limits it to Eclipse, so they're not gonna see your background stuff or anything like that. But of course, if you're willing to share your screen, make sure that everything is appropriate. When you come to office hours and share your screen, make sure that everything is appropriate, right? It can be embarrassing when it's not appropriate for both parties. So make sure that everything that you do, if you have inappropriate stuff, then put that into your secondary computer, or open up privacy mode, or just use Tor or something like that, right? All right. So if you just go to saros-project.org, it goes through how you can install this and use it. If you want to start your partnership and start using this, you find it's clunky, let me know. I don't have a partner that I've been able to test this out with, but it looks pretty slick. And if you don't like that one, there are about 50 other things just like it. Right? I only pulled that one out because it was free and because you could use it with Eclipse. This person has put down, for pair programming basically, dozens and dozens of tools that have facilitated this over the years. I will share all of this at the end of the day here on Piazza, all right? This link here. Some of it is language specific. Some of it is like Atom. If you use the Atom.io editor, you can use, there is a plugin that you can use to do basically the same thing, all right? And then in the comments, there are a bunch more, right? So it's not unique, right? This stuff has been around for at least 10 years that I know of, because I was using it back 10 years ago at least. But some of them are fly-by-night, some of them are startups, some of them are just a student project that then they forget about and don't care about, and they're gone, right? But it looks like that Saros is pretty solid, it's pretty stable, and it has pretty good support, so it's probably here to stay. The second, can partners be mismatched? One person being in honors and the other being in normal CS? Yes. I wouldn't call it normal though, it's just the main section. Yes, you can. You can team up with somebody in the other section because I've consolidated all the sections. In fact, you might not know it, we've got like we've actually got 6 sections of this course. 2 in the honors, there's the 150, the 160, which is in person, web conference, the 700, which is completely 100% online, and then we've also got a section through the BTA program, that's the Big Ten Academic Alliance program. So we've got at least one Buckeye that's taking this course. Hello, if you're out there. And I think at least one, Iowa is wild. What's Iowa? What it? Hawkeye. So I think we've got one Hawkeye out there too. Right? There are many people that you could collaborate with. We're currently at 166 people enrolled all across all sections for this course. Okay. So yes. So what's the difference between H and the main? Well, we'll get to that when we get to the syllabus. But as a preview, H, we're assuming that you already came from 155H, so you already have Java. So we're going to do PHP in the first part of the course. After that, it kind of blurs. There will be extra lectures for the honors section, but those will be posted online if you're interested in them. Right? But otherwise, a lot of the differences were taken away by the curricular adjustments from the academic Senate resolution that we'll talk about later. Anyway, the other tool that I want to give you, and I'll post this later today, is what's called a Gantt chart. So if you're the kind of person that is always finding yourself starting at the last second, or rushing at the last second, or just can't find a way to organize yourself, then one tool for self-organization, for project organization, is called a Gantt chart. This is at least a century old, I believe, the idea at least, where you take a project and then you break it down into smaller parts, right? So you are doing that top-down design, but you're doing it with respect to project management. Here's assignment 1. Here's project phase 1, project phase 2, project phase 3, etc. This is our timeline, right? And obviously we started on January 25th originally, but some tasks you can do in parallel. Some tasks require the finish, this task has to be done before this task, and so it's just a way of visualizing your tasks. Now, unfortunately, I'll zoom in here so everybody can see this. For assignment 1, right? Well, you need to read the assignment and understand it. Right? You need to design set up and outline your programs, including maybe, well, part 1, I need to open the file. Part 2, I need to process the file. Part 3, I need to do this, right? That's the kind of outline that you might need to make. Right? You already did lab 1. We'll talk about that in a second here. Come on, scroll. You need to design your test cases so that you have test cases that when you write your program, you can determine is it correct or not. Right? You need a first rough draft of your program. All right, you might have syntax errors. Hopefully you're writing correct programs to begin with, syntactically correct programs to begin with, but you might have bugs, right? That's okay, that's expected. If it runs perfectly on the first try, then great, you're done. But have a first rough draft first and plan to debug, to refactor, to clean it up, to document it. And then submit it and finalize it with the web grader. Right? Now, each one of these tasks, this is just my outline, right? If you think I can't do that in a day, I need 3 days. Fine, go in and change these dates. Right? For example, since we're 2 days late already, maybe I'll change this date to 1/27 through 1/28. Right? And then it changes where this is. You can see right here in red, this is the current day. Let me undo that. And that's a good indicator that we are behind. We have a task that is not completed yet that is in the past. I look at today's tasks and I see, oh, I should be setting up my program right now. I should be getting onto my my Eclipse and making the classes that are required, and maybe putting in the header that says that this is what the program is going to do. Okay, but once you're done with something, you can come back here and say, well, I'm half done with that, so 50%, and it shows you that you're 50% done with that. Once you're done with it, then mark it off, right? Yay, pat on the back, you made some progress, right? It's a way of visualizing your progress throughout this course. Now, I only did it for the first few phases. I'm leaving that task to identify the tasks for the other phases for yourself. This is not something that you have to turn in. This is not even something that you have to use. If you can self-organize and start early and give yourself enough time, and you've got your own way of organizing, that's perfectly fine, right? Unfortunately, the number one killer in this course is people starting way too late. Starting the day of, or maybe 48 hours before a due date. That's not going to cut it, right? This is 3 weeks, 2 weeks, 2 weeks, 2 weeks for a reason, right? There is that much work there, right? It's not like a computer science one where we had a weekly hack that was much smaller. These are much more substantial, right? And everybody's done here with now a lab one. So I'll go ahead and mark that as 100%. But if you've got a task that's still at 0% in the past, that's a good indicator that, oh, I really need to hunker down here and focus on this and get that task done today and catch up, right? If you get ahead, that's perfectly fine too, right? Just go ahead and update and give yourself some slack time. In fact, you can do that by, what I've done here is I've made it so that submit test with grader takes actually 2 days, right? I've built in 1 slack day in there so that if I get that done on that Thursday, then that Friday I'm free, right? And you'll note here that I did not designate anything for the weekends. So weekends are slack days, or maybe what you can context switch out and do that calculus assignment or whatever that you need to do, right? But this is completely on you to reorganize and reorganize this. It's also a good way of collaborating. John and Jane here, they team up and, yeah, I did that yesterday. Okay, great, let's go ahead and mark that off and then review the code together here to make sure that it's all correct, right? So a Gantt chart allows you to organize, do project management throughout a semester here. Use it or not, let me know if it helps you, right? Hopefully it'll help a lot of people this semester because traditionally there's about a 15-20% failure rate in this course, and 99% of them are because they don't start until way too late, right? And as you see, the nature of this course, where you've got project phase 1, phase 2, phase 3, if you don't do project 2, or if you don't do phase 2, there's no way that you can do phase 3, right? So you need to make sure that you're staying on task and that maybe you have to go back and redesign something, update it to fix some design flaw or something like that. That's fine too. That's part of the process. Okay, but I will post this. It's just an Excel file with a bunch of macros in it. I'll post this later today so that you can start using it if you want. Or of course, you can start manipulating it and changing it and playing around with it, like removing the labs if you want to. But the labs are part of that phase, right? That's why I put them in there. And of course, you'll need to take care of phase 4 and beyond, all right? You could cut and paste if you want, or you can identify, it took me 3 days actually to do that, so I'm gonna give myself 3 days on that part, but it only took me 1 day for that other part, so I'm going to go ahead and give myself less time on that next phase, right? It's all up to you, right? Self-organization, self-management. But I'm giving you a tool to help you with it, right? All right, so questions online here. For coding our programs, it is compulsory to use Eclipse, or can we use something? You can use IntelliJ, you can use NetBeans, BlueJ, you can use Vim if you want. You can use whatever you want. The only caveat there is that it has to work in the grader, right? And the project setup does require a certain setup. So if you are using IntelliJ, I think that we've got written instructions for how to do that. But if you're using something completely different, you might be on your own to figure out how to set up the project so that it works in the grader. Right? Will we be able to use the same schedule on Gantt you already made? If you want to, I'm just going to make it available to you. Right? All right. So With the remainder of our time here, let's go ahead and take a look at the course resources. And to do that, we're just going to jump right into Canvas here. Everybody should be familiar with this. Everybody's imported here. The main page here has our schedule for the course. You can see lab 1 was right there. Next week, we'll of course continue with Java, loops, arrays, methods, etc. That's what lab 2 covers pretty much. These are, we've got required reading, which one of them is included in the syllabus here. I'll go ahead and open that up right now. But also required watching. Now, I don't have pre-prepared videos for everything. Most notably, I don't have pre-prepared videos for object-oriented programming yet. Hopefully, I can get to that this summer, but of course, lecture will cover that here. All right? But otherwise, each day when we complete the lecture, I'll go ahead and post a link here to the YouTube recording. We are live streaming on YouTube right here, and the recording will be available immediately after. The assignments and their due dates are right here. Again, everything is due on Friday. All assignments are due on Friday at midnight. Design documents are due in Canvas, though, on Thursdays, I think. Or maybe that is Fridays. I forget. I forget what I set those to. Let's see. Let's check it out. The final draft. That's the final draft. Where's the... Okay, I don't have links in here. You'd have to go to the assignments to find out. Design document draft 1 due on February 19th. Is that a Thursday or Friday? Friday? Okay, so they're due on Friday too, just for consistency's sake. Thank you. All right, back to Canvas here. I've tried to consolidate all the resources as much as possible to one page. Of course, we've got course info, getting help, lab info, other resources. The course info here is just the YouTube playlist for the lectures, my live stream link here, and the in-person stuff right here. Getting help. There is our weekly schedule. All times are with respect to Central, right? So if you're across the globe, understand that all times are local here. We're not going to have anybody up at 1 a.m. doing stuff, right? But otherwise, we've got lectures. This lecture right here on Tuesdays and Thursdays. Chase has his first office hour on Mondays at 10. Help hour, I should say. And the last hour is on Friday by JL at 9:30. Right? So you can see that we tried to put more help hours on Fridays when things are due. But I'm going to tell you right now that if you're the type of person to wait till the last minute, there are many others like that, right? And Fridays can be quite busy. And not only that, but they only we only really have support up till 7. JL has 1 additional hour, but not up to midnight. So keep that in mind. We only have, I believe, 9 learning assistants and 2 course leaders. So we don't have as many office hours as, say, we had in Computer Science 1 last semester. But otherwise, if you want to introduce yourself, there's Ryan, JL. We've got pictures and bios of everybody on this page. So please go ahead and check them out. And they're all students just like you. They're all undergrads that have taken this course either last year or a couple years ago or something like that. So they know what the course is about. They know how to succeed in this course. Use them as a resource. Okay. There's the lab info, including the Zoom link to get there. I closed it already, but it's the same Zoom link to go to help sessions, to go to help hours. That's why we don't have any help hours on Wednesdays. It's because, well, they're there anyway, but they're there to help you primarily with lab. That doesn't mean that you can't go there and ask them questions about the project if you're already done with the lab. Right? You can ask them questions during any of those times. My help hours are 1 to 3. I forget what I put it in there. You can check it out. 1 to 3 Mondays and Wednesdays and maybe Fridays. I forget, but it's up there. And of course, I'll be online on Zoom along with everybody else. The Learning Assistant program has a bunch of information about their program. Maybe some of you want to become learning assistants next year. Now would be a good time to start talking about the program with the current LAs to find out, is it really as cool as it seems, right? And talking about the duties, the pay, the kind of stuff, and so you may eventually you may be able to apply for it, right? At the end of the semester. Any learning assistants in here right now, maybe for a different course? No? Okay. Then we've got a whole bunch of other resources, just not random resources, but check it out. There are free textbooks on Java. There are free websites and tutorials and stuff like that on data structures, algorithms, SQL, PHP, Java. Code Academy, for example, is a free online course if you want supplemental material. Okay? All right. Okay. Let's get into the syllabus. Again, the theme of this course is smart data structures and dumb code are a lot better than the other way around. That's a quote by Eric S. Raymond in The Cathedral and the Bazaar. Again, the prerequisites for this are technically Math 106. That's Calc 1 for those who don't know. Not that we're going to use any calc in this course. It's just there for mathematical maturity. But if you don't have that, you should be fine in this course. Or if you took it like 5 years ago and you don't remember what the first derivative of x squared is, who cares, right? But otherwise, you do need at least one high-level programming language. That means Python. It could be Java, JavaScript, C, C++, C#, whatever. You need to be able to program in at least one language already, right? That's the real prerequisite, okay? But otherwise, at the end of this course, you should be able to more easily pick up and learn a new programming language on your own. Maybe you'll want Python. Maybe you'll want C# and do some gaming on Unity or something like that. You should be able to use, recognize, and appreciate programs with an object-oriented flavor. You should be able to design a database backend application, basically CRUD application, create, retrieve, update, and destroy application. You should be able to understand and implement basic data structures as well as recognize how and when to leverage them to solve a problem. You should be able to identify and analyze basic algorithms as well. Okay. COVID accommodations here. If you are infected or have been exposed, please do not come. Just go ahead and attend virtually. All right. But as of right now, if your number NUID ends in an even number, you may attend on Tuesdays. If it ends in an odd number, you may attend on Thursdays. Again, it looks like, just like last semester, we'll be able to relax that almost immediately. But if you're in the 160 section, then that means that you signed up not to come to lecture physically ever. Likewise, the 700 section. Right? Otherwise, labs, you can those in the 150 or 160 section can choose to come in person or remotely. It looks like a lot of people just chose to do everything asynchronously and finish it on their own, though. Right? All help hours, all office hours are online only. We do have a student resource center down there that is closed. We do have an open lab that is available, but no learning assistants will not be down there physically. Right? There will be at least one learning assistant physically present in lab, though. Right? But that's it. Otherwise, all help hours are online only. Face covering policy, everybody looks great. Get your engineering one or get a cooler one, whatever. Of course, we've got that app too that you might need to, they said that you need to show it at the door. I haven't seen a single doorman anywhere here, so do make sure that you're fulfilling at least the spirit, even if nobody's there to check you. All right. Social distancing, of course, everybody needs to sit in a designated spot. Self-care curricular adjustments are things that we changed in this course. I've already mentioned a few of them. In response to a resolution put forth by the Faculty Senate in December. This is not watering down of courses. This is simply just what are the small changes that you can make in your course because in these difficult, challenging times. From my experience in fall, it seems like everybody pretty much adjusted well, but there's always things that we can do. For example, we no longer have a midterm and a final. We actually got rid of those in spring 2020. We had a midterm, but we didn't have a final because COVID hit. And so we said, all right, well, we don't need that. And we're continuing that into this semester. Traditionally, there has been a midterm and a final exam. That's usually 10, 15, 20% of your grade. We've eliminated those, right? The final assignment, that is assignment 8, typically a written theory-based assignment, is still assigned and required, but we're not going to grade it. You're not even going to submit it, right? We still want you to go through the assignment and do the work to prove to yourself that you're ready to move on with Computer Science 3, right, if you're moving on. The number of labs have been reduced to 14, of course, but not only that, we will drop your lowest lab grade. I think the lab that we cut was on recursion, which is just a retread of CS1. But in addition to that, if you miss a lab because you're just so sick because you got COVID or something like that, that's fine. We'll drop that lowest lab grade, right? Or if you missed the first lab for whatever reason because it took you a week to get to campus or whatever, or you didn't have connectivity for a week or something like that, that's fine. That's your one lab that we'll drop. For those in the honors section, the other, I'll talk. You can ignore that one. I'll talk to them about that when we get there. But otherwise, how do we get engineering masks? I don't know. I found mine in the mail. Where did you get the engineering? I don't know. Google UNL engineering masks, and you might be able to buy one, or just I don't know, write engineering on the one that you already have. They're not special. They're just regular masks with words slapped on them, right? Accommodations for students with disabilities that you need to go to the SSD office. With the elimination of exams, though, most accommodations are taken care of, right? Usually, the SSD office is sending us accommodations for exam taking, distraction-free environment, additional time or whatever, but we don't have that in this case. If you do feel yourself being overwhelmed psychologically in this course or in other courses or just in life in general, remember about CAPS. That's Counseling and Psychological Services. As students, you have free, I believe, unlimited ability to go and get counseling services as much as you need, right? And that's between you and the Counseling and Psychological Services staff there, right? They won't inform me that you went there. I don't want to know that you went there. They will, of course, keep, they have a Hippocratic oath, they have confidentiality, they won't be sharing that with anybody, right? So if you do feel that you're in need of counseling and psychological services, CAPS is free, right? All right. Here's the actual assessment. Again, 7 assignments, that's 74% of your grade. 13 labs, there are 14 labs, but we dropped the lowest one, so that translates to only 13 labs that are graded. That's about 26% of your grade, okay? The final letter grade will, of course, follow the regular old scale here. Labs are based on completion, so you get the 20 points or you don't, right? Assignments are based on, there are 8 assignments, but only 7 are graded. The 15-week policy, your last assignment is due, well, there are only 14 weeks, but it's still called the 15-week policy. Your final assignment is due on the last week of class. The last week of class, there is still another week of finals after that, but of course that's irrelevant to us because we don't have a final exam. Right? If you have questions about grading, make sure that you're discussing that with the grader first, and then if you can't get that resolved, you can come and see me. I am one of the graders though, so if you have a question about something that I graded, then you can come and see me immediately. Right? But otherwise, we'll show you what we mean by grading later on when we show you code post if you're not familiar with that already. Unfortunately, no late work is accepted. We've already cut it down to 14 weeks. We already lost the first day. We're somewhat behind already. All right. Web grader policy, it's got to work in the web grader. And if you haven't set up the project correctly on the project phases, it's not going to run. Right? So make sure that you're following that video step by step. Make sure that you're giving yourself enough time with that Gantt chart that if you have a problem, you come into office hours to get it resolved quickly, right, as soon as possible. Ignore that. Communication and getting help, our main line of communication is going to be Piazza. Second would be Zoom, right? Third would be email. If you absolutely have to email me, fine. But if you ask me a general question that would be of interest to the entire class, I'm going to say, great question. Let's take out over to Piazza so that everybody gets the benefit of the answer. On Piazza, you can be anonymous. You can identify yourself, but be anonymous to the rest of the class. Just do not post code on Piazza. Right? You can. not even lab code until after the lab is done, just so that people don't, get lazy and just cut and paste lab code. Lab code is, you are allowed to collaborate, but simply posting code and copy pasting code is not collaboration. Right? Okay. There's a blurb about the Learning Assistant program that I would encourage you to read. And of course, getting help. Where do you get help? How do you get help? Get help in the right way. Identify, when you go to office hours and you've got a question, make sure that you describe it as well as you can. If you've got screenshots on Piazza, those really help. Of course, make it into a private post if you can. Describe the problem that you're having as well as possible so that we're not, just doing guesswork. Also explain what steps have you already taken to try to resolve the problem, right? Because that helps us too. And it also helps you because it is kind of like what's called rubber duck debugging. If you're forced to explain it to somebody else, that means that you force yourself to, organize it in your own mind. 9 times out of 10, if you do that process, you solve it immediately, right? And you can see it on Piazza where we go back and forth. Well, did you try this? No. Did you try this? No. Did you try this? Okay, I figured it out. Right? Unfortunately, they don't then say, oh, I figured it out. Here's what was wrong. Here's what was wrong. Here's what was wrong. So that everybody else, oh, yeah, that's what's wrong with me too, right? It's kind of like the Stack Overflow questions that, oh, yeah, I solved here's my question. I've got a problem. I solved it. And they don't explain how they solved it. So 3 years later, somebody comes by because of a Google search and sees, I had that same problem, but they didn't say what they did to solve it. So I have no idea how to solve it, right? Be descriptive, right? You say, I forgot the semicolon, right? Hopefully it's a more sophisticated problem than that. But that's the idea, right? Try to communicate as much as possible because that communication process will help you to solve your own problems, okay? All right, I'll include that later. Any questions so far? Check online. Where will, I'll post it on Piazza and I'll post a Gantt chart in Piazza in response to, or at the end of the day, all right? Okay. All right, well, let's get into it. Our first topic is Java, right? Just a show of hands here, how many people have done Java already? A little bit? All right, good. Then that means that you're going to be learning something new for the first 3 weeks here, and that you'll use throughout the rest of the semester. So Java was born, when was Java born? Everybody did their first lab yesterday. When was Java born? 25 years ago? Or 25? 95? Oh, yeah. Geez. All right. Yes, it was 1995. Why was it created? Well, it was originally created as a programming language for cable boxes, right? And basically the designer, James Gosling, I think, he wanted a language that looked familiar. He wanted a language that had automatic memory management. He wanted a language where you write once, compile once, and run anywhere. In other words, you wouldn't have. It's not like C, where you write a C program, and then you want to run it on a Windows machine. You need a Windows C compiler, and it'll compile it for that machine, that hardware. Or I want to run it on a Mac. All right, you need a compiler for Mac, and it'll only run on that system. Java is different. You write it once, you compile it once. As long as that system has a Java virtual machine, or JVM, it'll run, right? So write once, compile once, run anywhere is the philosophy, right? It is a class-based object-oriented programming language. The translation there is that everything is a class or belongs to a class. So in C, I'll always go back to C here because the vast majority of people are coming from a C background with 155E. In C, everything is globally scoped. If you create a function, you can create a function and the function stands by itself. SQRT is a function in the math library. It exists everywhere, right? Anybody can use that function as long as they include that math library. Java is different. Java, everything is a class or belongs to a class. So you can't just have this function sitting out there. You actually have to put it inside of a class, right? A lot of people don't like it because that kind of approach because that means that you have to have a lot of boilerplate code. It's not a big deal though. Don't listen to their whining. Right? What are classes? Classes are simply units of code that are declared in their own source file. So yesterday when you did hello world, that was in a source file called helloworld.java. In general, it has to match. So if your class name is hello world with capital H, capital W, and lowercase everything else, then the source file has to have the same name. Right? If it doesn't, then it won't compile. Instead of compiling for an actual machine, for an actual processor, you compile for a JVM, Java Virtual Machine. You compile it into what's called Java bytecode. You're compiling it into a bunch of binary, but it's not binary that the machine understands. It's binary that the Java Virtual Machine understands. And the Java Virtual Machine lives on top of the processor. The Java Virtual Machine has been compiled for that processor. So it's basically kind of like an abstraction away from the hardware that you're running on. It doesn't matter if you're running on Mac. It doesn't matter if you're running on Windows. It'll all run the same because it's cross-platform. Yeah?
Does that make it any slower compared to like C programming?
Typically, yes. You pay a cost for that portability. That it is going to run slower. In general, right? It's not always the case. You can get performance that matches C, or just a little bit worse than it, but it'll never be as fast as a native program. Right? Yeah, you pay for, but the price for the most part, you're not. If your application is like some scientific application where you need, or you're a quant and you need GME is going through the roof and you need to execute that trade in a microsecond, you're not doing it in Java. you're choosing a C or C++ language to do all that stuff in, right? So it's for a different purpose, right? IDEs like Eclipse can hide a lot of these compilation details because when you actually hit that play button, the IDE, the Eclipse is continually compiling in the background and recompiling. So that if you type gibberish, then it'll immediately highlight in red because it's a syntax error, right? Classes are also organized into packages. They're simply just directories. They're just simply folders on where stuff is stored, so that you can put all your math stuff over here in this package, so that it's not getting mixed up in all of your sales stuff over here if you look ahead to the project or something. Basically, packages provide organization to your classes. Here's that Hello World program that you probably did yesterday, right? And we've got several components here. We've got a package declaration. This would be in a folder called UNL, in a subfolder called CSE. Right? That dot is a delimiter for subfolder or subdirectory. You can go as deep as you want. Usually it's top level to bottom level. So instead of csc.unl.edu, that is more specific to more general. We go in reverse on packages. Most general, because it's hierarchical. It's kind of like a tree. The most general is up here. EDU, if you wanted to have education. A lot of libraries begin with COM, commercial, right? And then under that, then they've got various other directories that they store stuff in and organize code. This one is simply just unl.csc, right? Then you've got a public class hello world, right? Usually class names are upper camel cased. So it's not going to be, this is syntactically correct as long as your source file is also lowercase h, but that's not how it's usually done. The style guides dictate that all classes should be upper camel cased, like this. Right? All functions should be lower camel cased. So if I had main foo bar, then I would, var, there we go. Then I would have a lower camel casing like that. But of course, this is not main foo bar, it's just main. Right? Likewise, variable names are lower camel cased. We'll get into variables here probably next time since we're running out of time. But a lot of familiarity here, right? What's something familiar from C? Say what? The main. You have a main, right? Every main you have a main entry point to every program because a program has a start. So you have to start somewhere. So you have a main method. Right? We don't call them functions in Java because they belong in a class. We call them methods, right? So who cares? I'll probably be calling them functions and methods. It's just a pedantic terminology, right? All right, so we've got a main. What else is familiar? Yeah. Yeah, so printing to the standard output. Print. You can also use printf, by the way. Right, that's in there. Or you could just use print. And what's the difference between print and println? ln is short for line. It'll insert the end line character for you. If you just use print, then it won't put the end line character in there for you. You need to explicitly put that in there, right? Using \n. How do you remember that's a backslash? Person facing right, they're leaning back. /, they're leaning forward. Right? Let me go ahead and restore that to println. And of course, if you use printf, then you, if you're familiar with print formatted style from C, then you can use that as well. Right? Other things that are syntactically familiar. For example, how did you know that? Where does the main begin and where does it end? How do you know where it begins and ends? Curly brackets, right? How do you know that this is a statement? Then this is the next statement. There's only one statement in the main. This is the next statement. Next statement. Semicolons. How do you know that something is a string? Right. Double quotes here. Single quotes are characters. So lots of stuff that you're already familiar with from C can be used here in Java, right? Semicolons end executable lines of code. Square brackets are used for arrays. We'll talk about arrays later on. And in particular, we won't use them. Instead, there are much better data structures in Java that are provided by the language than arrays. String literals, double quotes, right? That you can, and you can also have escape characters. If you want to tab over, then that's simply going to be \t. Right? \n, of course, would be the end line character, etc. Okay. Some other differences that you might be familiar with, and that might not be familiar with, is that there is no direct memory management. There's automated garbage collection. So if you're coming from a C background, if you created something using malloc, memory allocation, that created something on the heap. It gave you a chunk of memory so that you can store 50 integers or something like that. What did you have to do once you were done using that? Remember? If you allocate something, you have to, I gave you a bunch of memory, and okay, thanks, and then you throw it in the waste bin. That's garbage now, right? So give it back to me so that I can give it to some other process. What do you remember the function that you called? To free. You freed it up, right? You cleaned up after yourself. You asked for memory, like a library book. You check out your library book. If you just keep it, nobody else can get the benefit of it. If you throw it away, it's lost, right? And then at the termination of your program, then the operating system recollects it. But that's basically a memory leak if you do that. With Java, no problem, right? You don't have malloc. You don't have free. It takes care of all that stuff for you, right? Not that you can't have memory leaks in Java. You can by holding on to references, but we won't get that deep into it. It's portable, write once, compile once, run anywhere. They wanted this programming language to work on any cable box whatsoever, so they needed a machine-independent language, and that's why you originally developed it. It ended up not being used for that purpose. Instead, it's used for a whole other purpose, right? Like most programming language, they're conceived of to be used for one thing, and then they find their niche in other places. It's backwards compatible, mostly. We're currently, you downloaded Java yesterday or for your lab, hopefully. You downloaded version 13 or 14. Is 14 out of beta yet? Which version? Anybody remember? Okay. Well, we're at least on 13. I believe that we're on 13 on CSE. We can find out really quick here. When you hand your stuff in, we will be running Java version 15. Oh, wow. Oh no, yeah, it's on 15. So, wow. Okay, cool. We're on Java 15. In recent years, I think that they've had a target release date of a new version every 18 months, I want to say. I'm not sure, maybe a year. So the version numbers have jumped up quite a bit in the last couple of years. If you write something in Java now, then or if you wrote something in Java 25 years ago, it will still run on Java virtual machines today, right? That's what we mean by backwards compatibility. That they wanted to write it once and be done with it forever, so that that it would run in perpetuity the next 25 years. That's not necessarily the same with C, or other languages, I should say. There are single-line comments. There are multi-line comments. There are doc-style comments. So what do I mean by doc-style comments? Especially when you turn in your first assignments, you will need doc-style comments for documentation. And this is a doc-style comment. The author, me. Purpose, a basic hello world program, right? Just document, simple documentation like that. Date, maybe. And today's date is 28th, right? That's all we're really looking for in your first assignment, is that kind of documentation. You don't have to document every line. It would be really actually inappropriate to document single lines like this. This prints hello world to the standard output. That's terrible documentation, right? Code should be self-documenting. As long as you know Java, you know that system.out.println prints to the standard output, and you can clearly see what does it print to the standard output? Hello, world, right? This is completely superfluous kind of documentation. You don't do that, right? This is bad documentation, right? Good documentation tells you the what and the why, right? I wrote this function for this purpose. This is what it does. It expects these inputs, it produces this output. Why did I write this? Well, because we need to compute the square root or something, and the standard library doesn't have a square root function. It does. But the how does it do it? Does it use the Babylonian method? Does it use some Newtonian interpolation method? Does it use some derivatives? Who cares? You read the code. It's self-documenting, okay? Or you could say it at a high level that it uses the Newton's method for computing the square root. By the way, here's the Wikipedia article on it. Go see that, right? All right. With only about 3 minutes left here, really talk quickly about basic variables, and that's where we'll pick it up next time. So variables, Java is statically typed. All that means is, just like C, if you're going to use a variable, it has to be declared, both its name and its type. We've got int x is equal to 10. Double pi is equal to 3.14159. Char c is equal to single quotes for characters, a single character. By the way, if I didn't tell you that this was Java, would you be able to guess it? No, it's C, right? C style syntax. This is a direct copy-paste, basically, of that language. And in fact, lots of languages. I could cut and paste this same exact stuff into at least 3 or 4 other languages and have it work exactly like it would work in C. This would not work in C, though, unless you brought in a library to do it. A Boolean type is not in C, but we do have a Boolean type in Java. A Boolean can either be true, lowercase true, or it can be false, uppercase false. Right? So is student is equal to false. Right? It is not false. Right? It is not false. It is false, all lowercase. Okay? Questions so far? Yeah.
Can we still use like 0 and 1 for true and false?
Nope. That's because we've got. We did that. We used 0 and 1 in C because we were poor and we couldn't afford a real Boolean variable. Now we're richer, right? Because we cashed in our attendees on a GME, right? And now we can afford proper Boolean variables, and so we use the keywords true and false. Oops, I got rid of a semicolon there. All right. Okay, then that's where we'll pick it up next time. Now, do you need to use C in the future classes? Probably, especially with systems programming if you take an operating systems course. All right. Here's my outro. There we go.